Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we are going to implement experiment number 6, which is totally piece-wise experiment to simulate the bipolar junction transistor characteristics. So the circuit that we are going to simulate today, it looks like this. We have a bipolar junction transistor, and this is the collector, emitter, and base. We are going to connect the base to a current source. Let's call it I base. And we are going to connect the collector to a voltage source, a DC voltage source. Let's call it VCE. And the emitter is going to be connected to the ground. Okay? So this is the circuit that we are going to simulate today. We have 3 steps in this experiment. The first step is we want to plot the IC VCE curves. So the first step, step number 1, is to plot the IC VCE curves. So what we are going to do here in order to obtain these curves, which are supposed to look like this, eventually after we simulate, we are supposed to get curves like this for different values of I base. So we have here to do a DC sweep. So we'll do DC sweep for the voltage source VCE. So DC sweep for the voltage source VCE, and we are going to change the values of VCE from 0 to 8 volt with a step size of 0.01 volt. So this is the first step. We'll do DC sweep for VCE, for the voltage source VCE, from 0 to 8 with a step 0.0 volt. This should give us only one curve. But in order to get 3 curves for different values of I base, so for example, we want to plot a curve for I base equals 0.1 milliampere, and another curve for I base equals 0.3 milliampere, and the third curve for I base equals 0.5 milliampere. Here, we'll have to add another nested sweep inside the DC sweep. So we'll add, when we do the DC sweep, you will find that there is an option or a checkbox called nested sweep. This checkbox, you have to mark it with X, and then you click on it in order to set the nested sweep. When you set the nested sweep, you will have to specify that I base should change with the 3 values. You will find that one option called value list. In this value list, you will add the 3 values of I base, which are 0.1 milli, 0.3 milli, 0.5 milli, with a space between them. And then, like this, you set up the sweep, the DC sweep, and inside the DC sweep, there is a nested sweep for I base with 3 values. Once you do that, you are supposed to get 3 curves for IC against VCE for the 3 values of I base that you chose, which is 0.1, 0.3, and 0.5 milli. Once you do that, you will have to fill the following table. We have, we'll choose 2 values for VCE, which are important to us. 1 volt and 2.5 volt. So we'll choose the value of 1 volt and 2.5 volt of VCE, and then we'll start to measure the values of IC and I base at these points. So for the value of VCE, that is 1 volt, you are going to measure I base and IC, okay, for the 3 curves. Of course, for the first curve, I base is 0.1, for the second curve, I base is 0.3 milli, and for the third curve, I base is 0.5 milli. So for VCE equals 1 volt, you will have I base 1.1 milliampere, and I base equals 0.3 milliampere, and 0.5 milliampere. For these 3 values, you are going to measure using PSpice, using the cursor on PSpice or any other tool, you are going to measure what is the value of IC in each case. So you are going to measure IC here, and IC here. This is for the first point of VCE, which is 1 volt. You repeat the same thing for VCE equals 2.5 volt. So for 2.5 volt, you will have 3 points on the 3 curves. For the first point, I base will be 0.1 milliampere, second point 0.3 milliampere, and then 0.5 milliampere. For the 3 points, you are going to measure the values of IC. Once you do that, you will have 6 points where you have, for each point, you have I base and IC. For each of these 6 points, you are going to measure beta or calculate beta. What's beta? Beta is defined as IC over I base. So if you divide IC over I base, you are going to calculate beta in each case. And also, from beta, you can calculate the parameter alpha, which is beta over 1 plus beta. So you will get 6 values for alpha. So you have to fill this table, and you have to take a picture or copy this figure and paste it in your report. You are supposed to submit this report by the end of the lab, where you are going to just paste the picture of the curves, okay? Just mark or label the axes as IC, VCE, and show me which curve represents I base equals 0.1, I base equals 0.3, and 0.5. You have to make all the data clear on your curve. Then you fill the table, and you also put it in your report. Okay? Okay, in the second part of the experiment number 6 is we are going to plot the current gain beta versus I base and versus IC. So we are going to have 2 plots in this part, 2 plots, beta against I base and beta against IC. So what we are going to do here is we are going to fix the voltage VCE for 5 volt, and then we are going to sweep the current I base. We are going to sweep the current source I base using DC sweep, and we are going to sweep it between 10 micro ampere to 1 milliampere. And here, because of the wide range of the DC sweep of the current, we are not going to use linear sweep, we are going to use decayed sweep. So there is an option in PSpice to choose the type of sweep, so you choose decayed sweep instead of linear sweep. Okay? And when you choose decayed sweep, you have in the settings to choose 20 points per decade. So this is the setup of the experiment. Fix VCE to 5 volt, sweep I base between 10 microampere to 1 milliampere, and choose decayed sweep with 20 points per decade. Once you do that, you are going to plot, once you simulate the circuit, you are going to plot beta, which is, you can choose to plot IC over I base against I base, okay? And then you are supposed to get a curve that looks like this, which means that beta changes with the value of I base, right? You are required here to use the cursor or any other tool of the PSpice in order to calculate the value of beta maximum. What's the maximum beta, and at what value of I base it happens? So what is the value of I base at which beta maximum happens? Okay, so you are supposed to calculate these values, take a picture of the curve, put it in your report, and you have to indicate the values for beta maximum and I base where beta maximum occurs. And then once you do that, you are going to change the horizontal axis to IC. So instead of plotting beta, which is IC over I base, with I base, you are going to plot it with IC. And when you plot it with IC, using the same DC sweep, choose IC to change between 1 to 200 milliampere. So with the same DC sweep of I base, don't change the DC sweep, but you are going to change only the horizontal axis for the plot. Change the horizontal axis to IC and choose the horizontal axis to change between 1 milliampere to 200 milliampere. Okay, and you are supposed to get a curve that looks like this. Please calculate what is the value of beta maximum and find the value of IC at which beta maximum occurs. Okay, so this is the second part of the experiment. In the third part of experiment number 6, we are going to study the effect of temperature on the parameter beta. So this is beta against or versus temperature. So what we'll do is we'll do something similar to step number 2. We are going to plot beta against I base by fixing VCE to 5 volt and then sweeping I base from 10 microampere to 1 milliampere using decade sweep, 20 points per decade. But here we are going to add one extra part. We are going to do nested sweep. So we are going to check the box marked nested sweep, enable nested sweep, and inside the settings of the nested sweep, you are going to choose temperature, and you change the temperature for 3 values. So you are going to choose from the value list, you are going to choose the temperature to be negative 25 degrees, 25 degrees, and 125 degrees. When you do the nested sweep, what you expect to see is, you expect to see instead of one curve only, you are going to get 3 curves for the 3 different temperatures, negative 25, 25, 125. And then you are supposed to, before you copy the figure and paste it in the report, you are supposed to identify which curve is which. Which curve represents the curve for the 25, which curve represents the curve for negative 25, which curve represents the curve for 125. You are supposed to identify and tell me or write on top of them which curve represents which temperature. In addition to that, you are supposed, for each curve, you are supposed to calculate what is the value of beta maximum and at which point it happens. They might happen or occur at different values of I base. So for each curve, you are supposed to find the value of beta maximum and at which value of I base it will occur, and you identify this on the curve. Then you copy the curve and paste it on your report, which will you submit, you will submit at the end of the experiment. That's it for experiment number 6. Good luck.